Hey guys, happy Tuesday. Hopefully you all had a restful 3-day weekend. So we are going to come back and start a new unit. So today we're going to talk about properties of exponents. So maybe you guys remember powers and what 2 to the third power is and what does it do. So today we're going to kind of take it a step further at the high school level. What does it look like? What are properties of exponents? So they're little rules, little tricks that help us simplify and reduce things, and that's what we want to work on today. So you guys know the deal. Make sure you guys copy down this title, follow along, taking notes. Okay. So there's 5 in total properties that we're going to talk about, but today, we're only going to focus on these 2 right here. Product of powers and power of a power. So product of power, product just means it's a fancy way to say multiply. So what do I do when I have something like 3 to the second times 3 to the fifth? And again, that's what it means to be a product, is that you're multiplying. The next one is power of a power. So it's saying, hey, if you have something to the third power and then that guy has an exponent, something like a 2, what do we do then? What's the little tricks that we want to learn? So again, it makes our life a little bit easier when we're simplifying and reducing things. But let's recall, hopefully from middle school, what's something like 2 to the fifth power? What does that really mean? 2 to the fifth power. That means 2 times 2 times 2 times 2 times 2. How many times? 1, 2, 3, 4, 5. 5 times. And again, if you were asked to evaluate it, you actually have to multiply this out, right? So what's 2 times 2? Well, this gives us 4. 4 times the 2, that would give us 8. 8 times this other 2, that gives us 16. And then 16 times the last 2, that would give us 32. It basically just means, hey, can you multiply 2 out 5 times and we end up with 32. And then same thing with the next one, right? 3 to the fourth power, that just really means 3 times 3 times 3 times 3, 4 times. And when you go through and multiply, you can actually do it this way also. What's 3 times 3? 9. What's 3 times 3? 9. And then you multiply both of those together and we get 81. Again, that was at the middle school level. So now let's get a little vocab in here first and then I'll move on. So an exponent, guys, I do need you guys to copy these down. We are going to use vocabulary a lot for this unit. An exponent is a number or it can be a variable in the upper right corner, also referred to as a power. So this 4 right here is an exponent, or we can say to the power of 4. And it tells us how many times to multiply the base by itself. So again, 4, we see we have 1, 2, 3, 4 A's. And that A is what we call the base. It's the bottom number or variable in this case, which we are multiplying. Okay, so take a second, copy this down. When you're ready to go, hit play. All right, so let's take a look at the first property right here that's called product of powers. So product, guys, is just a fancy way to say multiply, 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 multiply. So I'll show you guys a few examples. Hopefully, let's see if you guys can spot the pattern. Okay, so product of powers, I'm multiplying r to the second. So this guy right here, r to the second means r times r. Okay, and then I have to multiply it by r to the third. Well, what's r to the third? R times itself, 1, 2, 3 times. Well, how many r's do I have in total? 1, 2, 3, 4, 5 r's being multiplied together. So we're going to say r to the fifth power. Okay, let's move on to the next one then. A to the fourth. That really just means a times a times a times a 4 times one more a here. There's one more that I have to multiply by. Okay, so I have 1, 2, 3, 4, 5 a's. I'm going to say a to the fifth power. Okay, so what would the next one be? Now I'm leaving a little empty space here. I had k to the seventh power. 1, 2, 3, 4, 5, 6, 7. So I had 1, 2, 3, 4, 5, 6, 7. How many more do I need to get all the way up to 9? I need 1 and I need 2. So these 2 right here, it's going to give me k to the second power. And again, we get k to the ninth. All right, so hopefully you guys have spotted it by this time, right? So what do we have to do when I have the same? Now here's the thing. I need to have the same base, 2 and 2, k and k, a and a, r and r, and I'm multiplying with all of these. If I have the same base and I'm multiplying, what can I do with these exponents? I simply can just add them together. So we're going to say 2 to the 5th power because I had the 3 and the 2. If I add them together, it gives me 5. So sorry, 2 to the 5th power. There we go. Okay, so product of powers. So I do need you guys to make sure you have this in your notes. When multiplying two terms with the same basis, so they have to have the same base, and you're multiplying, all you have to do is add those exponents. So take a second. When you're ready to move on, hit play. Okay, so let's go ahead and do a few examples here together, guys. So let's take a look at the first one. R to the 5th times r to the 3rd. Same bases, and I'm multiplying. What does the rule say? All I have to do is add those powers. We're going to get r. What's 5 plus 3? That gives us 8. All right, and sometimes you'll see people show their work like this. 5 plus 3. And again, what's 5 plus 3? That gives us 8 right there. That's what I'm looking for. That is our final simplified form. Okay, move on to the next one. I'm going to have x as my base times another x to the 6th power. So what do I do with these exponents? There's a 6 here, and there's what's here? Well, it's really a 1. So it's going to give us x to the 7th power. So whenever you don't see it, guys, technically there's a 1, a power of 1. Every base has a power of 1 if we don't see it. And that's our final answer there. Okay. The third one here. All right, sometimes students get confused. They're like, oh, these guys are in parentheses. But again, what happens when we have parentheses? What's technically going on in the middle? It's still multiplication. This is still w to the 3rd times w to the 4th. So same basis. Again, you have w and w, so w here, w here. So what am I going to do with those exponents? W to the 7th power. Okay, all I have to do is add those guys together. All right, next one. Now here I throw at you guys multiple variables. Okay, well how would this work? It's still multiplication. Now again, you want to keep x's with x's, y's with y's, v's with v's, n's with n's, right? So let's only work with this piece here, x to the 4th times x to the 6th. If I'm only working with this little section here, just like we did in the top first two problems, x to the 4th and x to the 2nd would give me x to the what? To the 6th power. Okay, added the exponents. Now let's move on to the next one. Y to the 3rd and y to the 7th. That's going to give me y to the 10th power, and that is it. That is our final answer. I can't combine the 6 and the 10 because again, the bases are different. X's and y's cannot combine. Those are two different things. Okay, so I want you guys to try this one down here. Take a second. When you're ready, hit play. Okay, same deal. I have a to the 5th times a to the 3rd. Well, I have 5 and 3, which gives me a to the 8th. Okay, move on to the next one, which is my b's. I have b to the 2nd times b to the 9th. It's like you have two of the first problems right together in one. Well, what's 9 plus 2? That gives me 11. And there we have it. Okay, the trickiest one is going to be this guy right here. Okay, so let's go ahead. Let me use a different color here. Actually, I'm going to go with red. Okay, so how do I multiply this one, right? Notice the 2 and the negative 3. So if I worry about the 2 and the negative 3, those are bases. Think of those as just numbers, okay? Think of those, these are what we call coefficients. Think of this as being 2 times negative 3. Ignore the x's for a second. What's 2 times negative 3? That is going to give us negative 6's. All right, so students tend to confuse that and we'll add those. No, be careful. Those are just regular coefficients, numbers in front. And we're multiplying, so we get negative 6. Now, let's take a look at my variables here. X to the 2nd times x to the 4th. What do I do with those guys? What's x to the 2nd times x to the 4th? All I have to do is add my exponents, and I get x to the 6th power. And there we have it. This is the one, again, students get confused a lot because they get so used to adding the exponents, they also want to add what we call the coefficients. No, those you actually still multiply like we've been normally doing. Okay. Now again, warning, please be careful. These problems, all I was doing in between all of them was multiplying. So again, if you ever are multiplying same bases, you just simply add those exponents. What happens when you're doing plus? It's a completely different story. Okay, this right here, actually, there's a 1 in front of the r. There's a 1 here. So how many r's to the fourth do I have together when I combine them? When I add them together, I would have 2r to the fourth. So please be careful. Okay, these are two separate situations. And we're mainly right now for this unit working with multiplying and same basis. Okay, the next one, guys, power to a power. All right, so this video is going to cut me off at about 15 minutes, and I do want you guys to hit and play part 2. And again, I'm trying to take my time because we are introducing it. I know it's completely new, so again, bear with me. All right, so for this one, see if you guys can spot the pattern as we go through it. So r to the second to the third power. Okay, well, what does this 3 tell me? How many copies of this do I have? I have 1, I have 2, and then I have a third copy. Okay, but then what does each individual one of these say? What does r to the second mean? That means r times r. Well, what does this r mean right here? That means r, whoops, r times r. And then what does this last little r mean here? That means r times r. So how many? 1, 2, 3, 4, 5, 6 r to the 6th power. So again, we had we had r to the second to the third power. Okay, maybe start thinking about how they got 6 there. Okay, let me do this next one. Let me use a different color so it doesn't blend in. Well, what does this 2 mean? How many copies of a to the fourth do I have? I have a to the fourth times a to the fourth because there was 2 copies. And then if I break this down even further, okay, a to the fourth means a times a times a times a, 4 times. Now let me do this one more time for the next one. That means a times a times a times a. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. A to the 8th power. And again, how do we go from a to the fourth to the second to the 8th? Hopefully we can kind of spot it at this point, right? Whenever you have a power being raised to another power, okay, you want to make sure you memorize these so you don't have to show all this extra little work here. You can, of course, but all you're really doing is you're multiplying these guys together. So 7 times 2 is going to give us 14, k to the 14th power. What's the 3 and the 2, these 2 powers, what do we do there? That's going to be 2 to the 6th power. So whenever you have an exponent getting kicked up to another exponent, that's when we multiply the powers. This is what we call power to a power. When you have an exponent raised to another power, we are going to be able to multiply these 2 guys together. Take a second, pause the video, guys. Okay, when you're ready, hit play. All right, guys, so we're going to go through these examples now. Again, these are going to deal with power to a power. So let's jump on the first one here. All right, so I have r to the 5th to the 3rd power. Again, I have an exponent of 5 getting kicked up to another exponent. So I'm actually going to just multiply those guys together. What's 5 times 3? That's going to give me r to the 15th power, and that's it. That's simplified. Same thing here. Let's go on to the next one. X to the 3rd to the 6th power. Power to power means me multiply those. What is 3 times 6? That's going to give me x to the 18th power, and that's all we can do. Okay? Now, these next 2 examples are one of the trickier ones, right? I start adding this extra little 2 coefficient. Tends to mess people up. Okay. So just kind of like what we multiplied up here, and we multiplied up here, same thing's going to happen. This guy technically has a 1 there, and this guy has a 1 there. Okay, so we're going to multiply these powers together. So they should say, what's 3? What's that 1 times the 3 there? 3. So it's going to be 2 to the 3rd power. And then what about this 1 times the 3? That's also going to be 3. So x to the 3rd power. I can actually take this a step further. What's 2 to the 3rd power? That's 2 times 2 times 2, which is 2 times 2 is 4. 4 times 2 is 8. So I can actually take this one step further. 8x to the 3rd power, and that's as simplified as we can take it. Okay, guys, I'm going to pause the video here. I want you guys to click on part 2, all right, and I'll resume with the next example.